Okay, this is a review of solving quadratic equations by completing the square. Kind of the key to this method is knowing how to figure out what to add to both sides. And in a moment we'll talk about this b over 2 squared value because that's pretty much the key. The other thing I'm looking for is making sure my setup is proper for completing the square. There are two conditions that have to be met. The first one to recognize is that the constant has been moved to the opposite side of the equation as the x squared and the x term, so my 6 over here is all by itself. And then the other thing to make sure is that the coefficient on x squared, or the number in front of x squared, is just a 1. So in this example, both of those two conditions have been met. So I'm going to go ahead and take away these little checks. We thought through that part. So now I know I'm ready to add something to both sides. And I'm just going to go ahead and say plus something because I'm going to be adding it there, and if I add it on the left, of course I must also add the same value on the right, and this is where our b squared divided by 2 comes into play. So our b value in this example is -6, and dividing that by 2 would give us a -3, and squaring that would give us a 9. So back up here, I'm going to go ahead and add 9 to both sides of the equation. Automatically now the left-hand side will factor. Like we've discussed, it will factor to the value of b divided by 2. So in this case, it will factor to x minus 3 quantity squared. So the factoring part really shouldn't be challenging in this process. It's really pretty much done for you. And then on the right hand side, just adding up our numbers, we'll get 15. What happens with the completing the square method is it turns into a situation that looks like the square root property, and that's exactly where we're at now. We have something squared equaling a number, therefore I'm just going to square root both sides. That pops out the x minus 3 on the left side, and I'm left with plus or minus the square root of 15 on the right. Of course, we consider if that simplifies, but in this case it does not. The only factors would be 3 and 5, no perfect squares. So we'll add 3 to both sides, and we'll call it good. So, nice way to leave our answer here would be x is equal to 3 plus or minus the square root of 15. And that would be good right there. If you like, you can take it to your solution set notation. In this example, if you were to take it to that solution set notation, we could write it as 3 minus the square root of 15 and 3 plus the square root of 15. So either of those notations would be great for your solution. Let's look at another one of these. The second example that we have here, again, if we talk about the two conditions, our constant is not yet moved over, so let's make that our first step. We're just going to kick the 9 to the other side. So that's done by subtraction, so we'll have a -9. And then the other condition, namely that the coefficient on x squared is 1, is already met, so we don't have to worry about that one. We're good to go there. So we're ready to figure out what to add to both sides. And if I run back down to my b divided by 2 squared, that's how I figure out what to add to both sides. That will look like 10 divided by 2 squared, which will be 5 squared, which means we should be adding 25 to both sides of the equation. Okay, again, the left-hand side immediately will factor to something squared. In this case, it's going to be an x plus 5 quantity squared. That's because my value of b over 2 was 5. And adding up on the right, we've got a 16 now. The square root property is our next step. We have something squared equaling a number. So we square root both sides to find x plus 5 is equal to plus or minus 4. The square root of 16 is just 4. If we subtract 5 from both sides of the equation, we have x equaling -5 plus or minus 4. But we can really take this further, so we can either say it's -5 plus 4, in which case we'd have a -1, or it's -5 minus 4, in which case we'd have a -9. So in our solution set notation, we're going to have a -9 and a -1. Okay, so that one's all done. Final example to look at here, we have x squared plus 5x plus 3 equaling 0. And so again, I do need to still move the constant to the other side. So x squared plus 5x is equal to -3. My coefficient on x squared is already a 1, so I don't have to worry about that. And I'm ready to figure out what to add to both sides. So in this case, my b value is 5. So we're going to have 5 divided by 2 squared. And that means 5 times 5 is 25, 2 times 2 is 4. So I'm going to be adding 25/4 to both sides of this equation. So we got some fractions involved with this one. So 25/4, 25/4. Again, the left-hand side we know is now going to factor as a quantity squared. And our little tip is it's just the value of b over 2, so it'll be x plus 5/2. On the right-hand side, if you like, you could do some fraction work here. I'll just go ahead and show how to do this by hand. So my -3 can be rewritten as -3 over 1. I'm trying to add it with 25/4. The least common denominator between the 1 and the 4 is just 4. So my first fraction will be multiplied top and bottom by 4. And that's going to clean up now on the right-hand side, because I'm really working with a -12 plus 25 for the numerator. That's really just 13 all over 4. So we added those two fractions. And now the square root property applies. So we'll square root both sides. That pops out our x plus 5/2. On the other side we have plus or minus the square root of 13 over 2. I'll just justify that briefly here. When we're square rooting a fraction, it's the same as considering the square root of the top over the square root of the bottom. And of course we know the square root of 4 is just 2, so that's how we're able to justify that part. So we're almost there. Next step to get x alone will be to subtract 5/2 from both sides. And at this point that would be fine to leave your answer written in that way. Because we do have a common denominator, you could write it as a single fraction. I'll show that when I put it in the solution set. So we could give our solution as a -5 minus square root of 13, all divided by 2, or -5 plus the square root of 13, all divided by 2. So again, either of those ways of leaving your solutions is just fine. So there were 3 examples of completing the square.